Greetings and salutations, and thank you for clicking on the video. Today we're going to talk about working with drives and file systems on your Linux computer, and this is a video for more advanced Linux users. However, if you're just starting out with Linux, this might be some information that you might want to tuck into the back of your brain. It might come in handy later on. Usually on this channel I do videos that are talking about stuff that you need to know to get started, but every now and again I like to deep dive into the system and show you some interesting things that you can do to tweak things up or work with different things within the system in ways that you might not be aware of. So that's what this video is all about. A couple of things to get straight before we get started. First of all, we're going to be talking about file systems in this video, and I am not referring to file structure at this point. The word file system actually has two meanings in the world of computers. The first one is how the system organizes files. So that would be like you're used to looking at the structure of files in the Linux system. Everything is mounted at slash and everything is under that. So that's one way to think of a file system. And the other way to think of it is a file system that is used on a hard drive. So it's the actual format that is used on the drive. And we're going to be talking about Ext4 today because that's kind of the de facto file system for most desktop Linux. If you're running Ubuntu, if you're running Debian or Linux Mint or Arch, and then you're probably using the Ext4 file system. Red Hat, Fedora, and CentOS these days want to set things up with XFS, and OpenSUSE offers Btrfs at install. So if you're using one of those distributions, you might not have the Ext4 file system on every partition, and so therefore I would encourage you to go off and find out more about XFS, Btrfs, whatever it is that you're working with. But those are more advanced file systems, usually designed for enterprise and servers. Home desktops and small businesses, things like that, get along just fine with the Ext4, and it takes care of itself most of the time. But it's kind of neat to be able to get into it and look around, so we're going to do that right now. And I have my notes down here. These are my notes, and it's not going to be every command that I have in the video today. It's just a few of them that I have written down so I can keep track of what I'm doing. I'm going to share this in the description to the video. You can do with it as you will. It's not a definitive guide. Just keep that in mind. It's just my notes. All right, so the first thing that we need to do is talk a little bit about block devices, which is what all of the drives that are hooked up to your computer are. A block device or a block storage device is something that the Linux kernel uses as a way to just store data. It's permanent storage. That's what it looks at. It doesn't care what kind of device it is. It doesn't care how it writes it. It doesn't care whether it's a SCSI type device, a SATA device, or whether it's IDE. None of that stuff matters to the kernel. That is handled elsewhere. As far as it's concerned, it's just sending data to a file. So it's represented as a file. Now, if you're at a GUI desktop and you have that nice little computer icon activated, then you can click on that and it'll pretty much show you all of the block devices on your system. And most desktops these days don't have that. Or if they don't have that, what happens if you're working in a terminal and you just need to find out very quickly? So the first command I'm actually going to show you is this one, which is LSBLK. That's ls block, and it shows us all of the block devices on this particular computer. And today we are looking at the Dell laptop machine, hooked up to it through SSH because it's easier to work on it through SSH than try and record video and do some of the stuff we're going to do with a machine that's recording video. Okay, so when you run ls block, it gives you this output, and over here it shows you SDA, and then a little tree here, SDA1, SDA2, SDA3, and then we have SDB and SDA or SDB1. And this tells us a couple of things. First of all, this tells us that these are SCSI devices or SATA devices, and that's how the system is dealing with them. If you have a really old computer that has like an old IDE drive on it, then you may see this represented as HD for hard drive. That's just the older system. Really doesn't matter. That's just how it represents drives. And then down here you see SR, and this is drive O. That would be the DVD drive. These two columns are just internal information for folks who would be like debugging a kernel. This is the exact address that the kernel uses to speak to this device directly, and then we get over here to size, and that is very useful to know because it will help you identify exactly what drive you're looking at. So if you know, for instance, that you have a 250 gigabyte drive and a 1 terabyte drive in your system, for instance, this is going to tell you which one of these it is. And then over here it shows us what it is. It's a disk or a partition, and then there's the mount point. Now if you see something at the mount point, that means that this is mounted to the file system. It is actually part of that Linux Unix file structure at this point. And it's a good thing to keep in mind because that means that we have access to it. And in this case, on this machine, we have the root partition, we have a swap space, which is not technically mounted in the file system, but it's active. That's what it's showing us. And then here we have home, which is the home directory that is living on a separate partition on that drive. For SDB, nothing is mounted, which means that that drive is not mounted. And we're not going to worry about working with CDs or DVDs at a command prompt today, so that's something that you would very, very rarely ever have to do, and I'm not even going to get into that. So those are the devices that are on the system. So these names over here, SDA, SDA1, what are these exactly? What does this mean? Well, what it means is that in the dev directory, which is a system directory that lives on your system, there are files in there that represent these drives, and so that gives you, the user, and programs the ability to interact with them by just calling up these file names. Remember, Linux and Unix, everything is represented by a file. Your drive, your mouse, everything's a file. Doesn't matter, it's a file. So that makes it real easy for people who are interacting with those to be able to do that in a real logical way. So the only thing we don't get here is the file system. It's not showing us what the file systems are on these drives. And to get that, we're going to use a different command, and we're going to have to do this as root. So we have to have elevated privileges because this gives us some privileged information. And if I run this command, give it my password, takes it a couple of seconds to get through this sometimes because it has to kind of scan the system. Actually, I know what it's doing. It's waking up that external hard drive, spinning it up. So what it gave us on output here, it shows us the exact dev here, where it is in the dev directory, SDA1, SDA2, SDA3. And you notice we're not seeing the devices here. We're not seeing the disks. We're just seeing the partitions because we're really interested in file systems. If there's a label, it'll show it to us. There's only one drive here that has a label, and then it'll also show us the UUID. What is a UUID? It is a universal unique identifier that a partition on a drive gets when it is created, and this helps the system keep up with what goes where, because up here where it says dev SDA1, SDA2, and all this stuff, if I swap the cables on these two drives, let's say that they're two internal drives, then what's going to happen is that what was SDA becomes SDB, and so therefore this can get confusing, and the system, like if you move drives around, it might not be able to boot. If it uses UUIDs to find where the drives are when it boots up, then it can actually find the right drive even if you move it around and it changes to SDB or whatever the deal is. So that's what that's all about. But what we're really interested in is right here where it says system type, and it's got Ext4. This is swap Ext4, so all of these drives are Ext4, so we know that. So there you go. Those are the first two commands that you need to know, is LSBLK and block ID there. Very useful to have around. Okay, so now that we've kind of figured all that stuff out, we can start diving into some other things and look at some useful stuff that you'll need to know. When you plug in an external drive on your system, usually on the desktop a little icon pops up, and if you right click on that icon, you will see that you can safely remove the drive or you can eject the drive. Either one of those issues this command And what it does is it just tells the system that any data that it has sitting in memory that needs to be written to a drive, go ahead and take care of that now. And before you start messing around with your system as far as like looking at file systems and stuff, it might be a good idea to go ahead and do this just in case. And if you're troubleshooting a problem and you know that your system just may crash or freeze up, you might want to do this as well. So that command is sync, and it just goes and it does it. You're not going to get any output on the screen. It's just going to make sure that all of the data is written from the cache to the drives. So that's a good thing to know. Usually the unmount command, if you're doing things at a terminal, will take care of that first, but if you want to be double sure, there you go. So the first really useful thing I'm going to show you here is fsck. And this is how you can check the file system on a drive. Now, fsck is an internal command to Linux that when your computer boots up, what it does basically is if the drive does not mount cleanly, if it comes back and says there's a problem here, then your system will trigger fsck, and fsck will go through and check the file system and attempt to repair it. If you are somebody who's used MS-DOS or Windows for years, then you're probably familiar with CheckDisk, that utility. Same deal here, this is just in Linux. fsck, like I said, is automatically called up when the computer boots if it thinks anything funny is going on. But you might want to use this for an external drive that is not going to work with that process. It's something that's not automatically mounted when it boots up. So to do that, you would issue the fsck command. So I'm going to show you how to do that first. You have to do it as root. And on this system, I am going to fsck, and I'm going to do dev sdb1, which we know from what we looked at before is the file system. It's an Ext4 file system on the second hard drive that's plugged into this machine. Now, it is very important that you do not try to fsck a drive which is currently mounted to the system. Okay, you do not want this file system to be mounted. fsck should stop you. It should say, you can't do this, it's mounted to the system. But if that doesn't catch it and it actually runs for some reason, it will most likely trash the file system. So we know this isn't mounted, so it's okay. So we're going to issue that command, and it goes out and checks that drive. And all you're looking for is this right here. We have the label for that file system, which is WD backup, and it says, guess what? That is clean. And it gives us some information here about what it did. If it had any problems, it would attempt to repair it, and you'd get lots of output on the screen. So we know that drive is nice and clean, no problem there. We are good to go. Now, what about fsck like on your home partition or your root partition? There's a couple of ways to do that. You can boot the system off of a live DVD, and then you can run LSBLK, and it'll show you what devices those are, and then you can run fsck that way. But what most people are probably going to end up doing is just forcing the system to do it at boot time. And you would do this if you thought something funky was going on. Let's say that your system crashed, it locked up, you had to use the power button, hold it down to get it to shut down, and you just want to be double sure that everything's okay. So you can force the fsck command to run at startup. And that's pretty easy to do. What we need to do is create what is called a flag file, which will tell the system when it boots up to go ahead and run fsck. And to do that, sudo touch, and we're going to put this in the root directory, and the name of the file is forcefsck. Just that simple. Make sure I typed that correctly. Yes, I did. And now it's done it. You don't get any output on the screen. So what we're going to do now is let's just go ahead and switch to the root directory, and then we'll list the storage there, and you see that we have that file. So the next time this system boots up, it's going to run fsck on all of the partitions on the drives that are automatically mounted. And I'm going to talk a little bit more about how that does that a little bit later on when we get to another part of the video. But just keep that in mind. I'll show you what order that does that and how you set that. Okay, so we are here in the root partition, which is actually where we want to be, because the next thing I want to show you is lost and found, and I want to show you how to get to it. Most of the time it's going to be completely empty, but this is a little folder directory that is created by fsck, and it is a place where it sticks anything in the file system that doesn't have a home. If it is what's known as a lost inode, and it's just kind of like data that's not connected up anywhere, then it'll stick it in here, and you can look in there to see if anything is in that folder. And the way you would do that is you'd have to do it as root. Okay, sudo is not going to work, so I'll give you a for instance here. Let's do sudo cd and then lost. Let's see, just type in lost and autofill, it finds it. Okay, can't do it. It's not, it doesn't understand. What are you trying to do there? So how do you get to this? You can't do it as a regular user. You can't do it as sudo. You have to actually become the root user. And in most systems these days, the root user account is actually locked. You can't log in and be root user. So if you are using Ubuntu or any system that locks that account by default, I think Manjaro does that as well, Arch Linux can be configured that way, then what you will need to do is to fool the system to make it think that you're the root user and you're not actually the root user. So we'll do sudo/s. Okay, and now you see my prompt change color, so I'm technically root. And be very careful when running in this particular mode, because anything that you type, the system will take literally, and it will just do. You can delete your home folder right now. You could do all kinds of damage, so do be careful. But all we want to do is look in this stupid folder, and I'm going to list the storage in there, and you're going to see that it's empty. There really isn't anything in here. Okay, and when I do all you see is dot and dot dot, which represents the current directory and the directory above it. There's nothing there. And that's good. That means that we don't have any loose files or bad inodes that got stuck in there and the system didn't know what to do with it. So that's just all good. You probably will never have to do this, because Ext4 is a journaling file system, which means that it keeps a running log of everything that it does as far as writing files are concerned. So if the system has a hard crash and you have a bunch of files open, it will revert to the journal the next time that it boots up, and it will say, what was I doing? Oh, I did that, I wrote this, and it'll just pick up where it's left off. If you have a non-journaling file system like the old Ext2 or FAT32 in the Windows world, those old systems, those systems could get really screwed up if the computer just stopped working and the cache didn't get written out and the files weren't closed out properly. Well, the journal kind of protects you from that, so that's why you don't even have to really worry about that. So we can go ahead and just exit to get out of sudo s mode, and let's see, and just cd will take us back to the home folder so we can talk about more interesting stuff here. So that's pretty much all you really need to know about fsck. You can fsck any file system on your computer, the Ext4 file system that is, and it will check it out and make sure that it's okay. You cannot do a mounted file system, so you will have to boot from a live DVD or USB stick if you want to check the drives that are mounted at startup on your machine. And then if you think something goofy happened, you might want to look in lost and found, but you don't have to. You will find a lost and found folder on every directory for your system. Okay, so let me go ahead and move on to the next part here. I want to talk about SSDs and trim in Linux, because this is a subject that people get very confused about. They don't know what trim is, and they don't know whether they need to use it on their computers. So, okay, let's talk about a little bit about what trim is. If you have a computer that has a solid-state drive, then you want to have some sort of trim support happening somewhere. Years ago in Windows 7, you used to have to get into the command prompt there and type in a command to activate this. and it would run all the time. And Linux had a similar way of doing that. What you would do is when you install your system, you would add an option to the file system table, the fstab file, called discard, and that would activate this every time that a file was deleted off your system. Then the SSD would go into trim mode, and it would move the data around to clear the blocks. See, what happens is that as you use an SSD, you write to it and you delete from it. When the file system deletes, the SSD doesn't necessarily actually remove the data because of the way it writes it. It writes it in these big blocks, see? So if you just remove a little bit of data that only takes up part of the block, the SSD is not going to go to all the trouble to move everything else and reorganize all that. And so what it does is it just marks that block as in use, even though that file's not there anymore, or some of the files stored in the block aren't there. And after a while, this starts to slow down performance for an SSD. So what it needs to do is it needs to talk to the file system and it needs to figure out exactly what it can just go ahead and wipe the block and how it can move that data around. Think of it as sort of like a defrag for SSDs. Well, in Linux, you can at any time use the fstrim command to do that. So on this particular machine that we're looking at for an example, we don't have SSDs. This machine actually has a hybrid drive, which is part SSD and part spinning drive. So we don't use the trim command on that. But if it was, then you could do fstrim, and then you pick the mount point. So we're really just going to do the file system. And let's say that the SSD in question would be the one that contained your operating system. Then all you would do is fire that off, and it would take off and do that. And you do it as root, by the way. And what that's going to do is it's going to put the SSD into trim mode, and it's going to go through and it's going to clear out its blocks. It's going to move the data around, not box, but blocks. It's going to go nuts for a little while, about 5 or 10 minutes. As I said, originally what you would do to do this is that you would add this. Let me go ahead and open this up in an editor. So I want nano etc, and then we want fstab. I got it wrong. Oh, that's what I did wrong. Duh. Noan. That's cool. Where'd that come from? I was trying to type nano. Try that again. Okay, here is our file system table file. And this is what the computer uses to mount up file systems when it starts up. So over here, we have options and that you can add. And here is what you would do is you would add here just this, like this. If let's say that this first partition was an SSD drive. So what I would do to activate trim all the time is to come over here and then add discard with a comma. And if I wanted it to work, I would spell it correctly. Okay, no space there. And if I did that, what that would do is that every time that a file was deleted from that drive, then the drive would go into trim mode and it would clear the block. Well, that hits performance as well. So we have a situation. You can either manually run fstrim every now and again, or you can put discard in the fstab file, and that will have trim activated all the time. Now, how this is handled is different depending on which distribution you're running. So the last time I looked, in Arch Linux, it will automatically kick discard on with the certain installers will turn that on automatically so that if it detects that it's an SSD, it'll turn it on. Well, that's not a good idea. So if you're running something that doesn't have the function that I'm about to show you that Ubuntu has, then you might want to just do it manually. I mean, like, you can do that, like, depends on how much you use your system, once a month or whatever. But in the Ubuntu world, we don't have to worry about all that. So I'm going to go ahead and exit this. No, I don't want to type that out. Thank you. Okay, because what they have done is we have a compromise. As of Ubuntu 14.04, we now have automatic trim that kicks in about once a week, takes care of this completely automatically, and we don't have to deal with it. This started with Ubuntu 14.04, so it's in Linux Mint 17 series, anything but based on Ubuntu 14.04, and it also works in 16.04. This is an Ubuntu feature I'm about to show you. However, there's a kind of a tricky thing that happens in Ubuntu 14.04 that I'm going to show you right now. Since this machine that we're using for an example is running Ubuntu 14.04 as a base, it's Linux Mint 17.3, then it qualifies for what I'm about to show you. So what we want to do is we're going to go back to the Etsy directory. Okay, I'm going to go to Etsy. All right, and then I'm going to switch to another directory, and this directory is cron.weekly. Okay, list the storage there, and now you see that we have some scripts in there. These are commands that the system runs once a week just to kind of fix things up. So what it's doing here is it's doing some things with app to make sure that the index is correct. Over here we got the mandb command that goes through and makes sure that all the manual pages are there and hooked up right. And then we also have fstrim. And this is the one that we're going to be looking at. So let me go ahead and clear the screen. And then I am going to once again use nano to look at this file. And the name of the file is fstrim. We can let that autofill. All right, so this is what's in this file. And it's just this one command right here. It says to execute this command, which is fstrim all. And what this does is once a week, it just goes out, all the SSDs, and it fixes them. However, since this is Ubuntu 14.04, you will notice that we have this message here that's telling us that it's only going to do this automatically for Intel and Samsung SSDs by default. Because back in those days, when 2014, when this was first introduced in Ubuntu, some of the SSDs would kind of get goofy when you put them in trim mode. And if there was a lot of stuff being written to them at that time, it might lose that data. So what they did was they made it so that you had to come in here and add something to the end of the line here in order to skip the model check function. This does not count in Ubuntu 16.04 or Linux Mint 18, gang. This is not there at all. The Ubuntu dropped that later on because those drives got their stuff in order, and they figured that they could go ahead and safely do that. So that's exactly what we have going on here. Okay, so let me get my cursor to the right place. And what you would do is if you're running like Linux Mint 17.3 and you want it to trim your SSD, then you just have to add this part right here where it says no model check. So I'm just going to cut and paste that to make it like super easy. Oop, I didn't want to do that. Go ahead and paste that there. Oop. Why is it putting something else in there? Hold on, let's do that again. Copy. And now paste. There we go. So you would add that to the end of that, and then you would save this script, and what it would do is if you were running something other than an Intel or a Samsung, it would check that out. By the way, if you're using an OCZ brand, you don't need the no model check thing at the end there to get that to work. And also keep in mind, once again, this is just for Ubuntu 14.04. So what does this do? Basically, once a week, it goes out and it runs the trim command and on all of your SSDs and takes care of it for you. So there's what you need to know about fstrim. And even though I have one machine that has a pure SSD in it, and what I do is about once every couple of months, I'll go in there and run the fstrim command on that drive manually so that it will I make sure that it gets done just in case the weekly cron job doesn't run. So there you go, just a little bit of information about that for your SSD. I'm sure that there's a lot of folks out there who are running Linux Mint 17.3 that didn't even know that was going on, or Ubuntu 16.04, so you might want to check into that. And Also, like I said, in Manjaro, you could set up that weekly cron job yourself if you wanted to, or Arch, and you could just do exactly the same thing. I just gave you all the information that you could use to create that script, and then you could put it in cron weekly, and it would take off and do that, assuming that that's how those systems are set up. I think they are, so it should work. Okay, moving on now to another thing to talk about. Now, I've shown this in videos before, and this is actually kind of a really cool thing about the Ext4 file system that I like, is that Ext4 is very, very good about not fragmenting itself as it stores files and as it, you delete files and then add files to the system. So those of you who have worked with Windows for years may remember that once a week or once a month you had to defrag the system. I think starting with Windows 7 they have that set up as a weekly job that runs in the task manager there. Get a sip of coffee. But in Linux you really don't have to worry about that if you're running Ext4. The average desktop user should never have to defrag their system, but you can. And I'm going to show you how to do that today. So to do that, you do it as a root user. And the command is E4 Defrag. Okay. And then you need to give it a place to defragment. You're just giving it a directory. So on this computer, if I would just give it the root directory, then it would defragment the first partition on the drive, which is where the operating system is stored. And let's see if it needs defragmenting first. So you can execute the command and then give it the little -C at the end, and now it's just going to go out and do it. It's going to check it. Shouldn't take too long for it to do this. Let's see what it does. So it's now going out and it's checking everything out on that root partition, and it's going to come back and it's going to tell us if the partition needs defragmenting. I can guarantee that it won't, simply because that partition is nowhere near full. So if your drives are not really full, or if your drives are not containing a whole bunch of really large files like videos and virtual machine files and things like that, then you probably will never ever have to use E4 Defrag. And as you can see on that particular drive right there, the fragmentation score is 0. So you do not have to do that. Alright, so let me show you a couple of other things about it. E4 Defrag will do any directory on the system. So if I want to, for some reason, just defragment a particular directory, I can do that as well. So let's go to... Did I type that correctly this time? Yes, you did. That's good. Okay, so I'm going to tell it specifically where to go this time. I'm going to say go to Home. Okay, and then I'm going to have it do my son's directory. He's got a lot of games in there, so he's got a lot of files. And I'm just going to turn this thing loose. And now it went through and it says that everything is not, there's no defragmentation whatsoever. Good to go. Or whatever it found it couldn't defragment. So let's see, failure 566 out of 566. I guess there's some files in there, or that could mean that it just didn't do anything. But either way, if there was something that it could defragment, then it would do it. Let's do something where we might find some fragmentation. So let's do Joe, and then well, let's have it go through Google Chrome. Just the, well, that's not going to work. Hold on. Oh, that's, okay, no, I know where that is. I'll just do config. All right, so we're going to go through that particular directory. And now it scanned all through those files. And let me just get that above there so we can see. So that's how that works. Pretty cool, huh? Clear the screen. So that would be kind of useful if you had a directory that had a bunch of video files in it, virtual machines, and you just wanted to get things straight. You could do that. But like I said, for the average desktop user, you will never, ever have to use E4 Defrag. and you can check to see the fragmentation level, but I would bet that it would come back 0 on your system. And the reason why is because the Ext4 file system, when it writes data to the drive, it does it in such a way that it leaves room. It doesn't try and cram everything toward the front of the file system. It actually spreads things out in a logical way. It gives it plenty of room to grow. So, like I said, as long as there's plenty of free space on your system, you should not have any fragmentation problems. Speaking of free space, it's the last thing I want to show you in this particular video. And this is kind of cool. So, when you set up your Ext4 file systems, or when the installer does it, you will notice that the drives do not come up with the reported amount of space available that you might think that they should have. So in this case, we just ran the df command, which is disk free, and this shows us exactly what's going on with all of the mounted file systems on your computer. Now, some of these are not actually hard drives, so look for dev calls here to see what we're looking at. So there's dev SDA1 and SDA3 right there. These are the currently mounted file systems and how much space is being used in them. So let's look at SDA1 here. You'll notice that we've got used 6.3 or 6.2 gigabytes, got 16 gigs available, and then it tells me that 29% of that space is used, and it tells me where it's mounted. Same thing with the home folder down here. Okay, if you do this and you look up, like for instance, when I created this root partition, that root partition is 25 gigabytes, but it's only showing 23 available. And the reason why it's doing that is because Ext4 sets aside 5% of the available blocks on the disk for the root user when it installs. That's the default. Why does it do that? Well, if those crazy regular users out there somehow manage to completely fill up a hard drive where there is no space available, and they're getting messages that says not enough space on the drive, the root user is ensured to have some place to work so he can fix the problem. It also helps the file system to keep things less defragmented because it can, like I said, it keeps that space in reserve, and it can move things around to lower the fragmentation chances, and that's how that works. Now, that might not be cool with you. You might have a situation where you're using a smaller drive and this thing's taking 5% away from it, and you're looking up at it and going, whoa, what's up? You know, that's not cool. Well, you can change that. If the drive is over 50 gigabytes in size, the partition that we're talking about, then you can use this command safely and it won't hurt anything. I would recommend not using it on your root partition, just your home partition. But if you have everything in one big partition, that's how your system is set up, you could probably use it and be all right. And what we're going to do is we're going to tell Ext4 not to reserve so much space. And we're going to use this command down here, tune to fs. So it's pretty simple. What we will do is, let me go ahead and I'm going to run LSBLK so I have that information in front of me. Okay. And then the command that we're going to run is sudo tune to fs. All right. And we're going to use -m, and we're going to make it 1% of the drive that is set aside for the root user. Now, since we're doing this on such a big drive, 1% is plenty of space, probably. So let's do dev, and in this case, the one that we want to do it to is the home folder on this right here, just to reclaim a little bit of that space. So that would be SDA3. Okay, and my notes are getting in the way, so I'm going to go ahead and close that because we won't need to go back to that anyway. Don't save the changes. All right, so let's see what it does. Okay, so it did that. Now that is a permanent setting change, and I don't know whether you can raise it back up, which we're going to find out here. So if I want to make that 5, long as there's 5% available, it should do it. Yes. So just making sure there. That was a loose end I didn't check out before. So you can lower that. And now if we run df, so remember the numbers up here. Take a look at that on this file system. It says available on this particular SD3 is 432 gigs. So let's see what we did to fix that. So let's do df disk free h. Let's see here, the available space is what should go up. So let's look at available. So now we have 282 gigs available, and we had before 264. So we've actually gained 20 gigabytes of space by doing that. So that's a cool command to know. And it is reversible as long as the drive has the free space that it can reserve for the root user. So if you want to get a little bit more out of the drive, you can do that. You can also set that to 0, but the danger there when you set it to 0, when you use this command and instead of putting a 1 there, you put a 0, what that will do is nothing's reserved. So if that drive does ever happen to fill up completely, the system might just crash, just can't access it, can't do anything with it because it can't write to it or something like that. So I would avoid that. 1%, set it low. There you go. So thank you for watching the video, gang. Like I said, every now and again I like to take a deep dive into this stuff and show you guys around and might learn something. There's one more thing I want to show you before I wrap up the video, just for those of you who are new to Linux and maybe you don't know how this works, okay? What if you take an external hard drive and you plug it into the system and you're working at a terminal, or you do not have a GUI available? How do you work with that drive? And it's the same thing with DVDs. They're not automatically going to mount. So how do you do that? I'm going to show you how to mount and unmount drives from the system so that you can do things with them. We're going to use some of the stuff here that we've learned on this drive. So let's just do the ls block again, just so we're familiar with it. Nothing wrong with typing that command over again. And the one that we want to mount is SBD, SDB1 right there, that partition, because it's not mounted anywhere in the file system. And that represents my external backup drive. Okay, so the command to do that would be mount, well, sudo, you have to do it as a root user, mount. Okay, now we got to figure out where we're going to put it. Well, we can just go ahead and put in dev sd sdb1. Make sure we got that correct. Okay, now where are we going to put this thing? Well, there are two folders in the file system that stuff is normally mounted into when you mount an external drive. There's media. And if you do it in media, that means it'll probably show up on your desktop. That's how the desktop does it. It uses that media drive for things like CD-ROMs, flash drives, SD cards, anything that mounts that way. You plug it in, and the desktop automatically mounts it as you, the user, and then it creates the icon on the desktop. But there's an older school way of doing this, and that is to use the MNT directory, which you may have noticed sitting there. And this is a directory that's normally empty, and it's used for temporarily mounting things that you want to mess around with. So let's go ahead and do that. Didn't get any output on the screen. How do I know it's mounted? Well, let's go to that directory. So we'll go to cd mnt nt, thank you. Alright, list that storage. And now you see the stuff that's on my drive. So we have a lost and found folder there because we ran fsck on there. It's there. And then we have access to, let's see here, if we go to cd home, autofill, list the storage, there's my backup. Now this lost and found here is there because I backed up the home folder on another machine that had a lost and found. This is actually a copy of the lost and found folder from the other one. It shouldn't be there, but that's just the way the backup software is set to work. It just takes everything in the home directory there and dumps it over, and since that particular home directory is on a separate partition, that's why you see lost and found. So you can go in here and you can work with the file system, and you can do whatever you need to do because this is now mounted to the file system on the computer. So there's my backed up file system right there. Okay, so now when you're done with it, how do you get rid of it? Well, here's what you would want to do. First of all, you will need to get out of where you are, because if you are logged into the directory and then you try and unmount this device, what it's going to do is it's going to say, you can't do it. So let's just do cd, which will take us to the home directory. And now to unmount that device, we do that command like this. So it'd be sudo umount, okay, and then just tell it what device we're doing that with. It's dev sdb1, like that, and now it should unmount this device. Yep. So if we cd into mnt, list of storage, you see it's now empty. The unmount command will run the sync to make sure that everything gets written, and then it will unmount it from the file system on the computer you're on. So if you have to work in a file system, this is where you can mount it. That's why you see the mnt directory is in here. So let's just list the storage here. It's right there. It's usually empty unless you absolutely need it. So there you go. A little bit of information you can go off and play with and do with what you will. Thank you for watching the video. Love to hear your comments and feedback, so send those in. Also, check out Easy Linux on the web, check out Easy Linux on Facebook, and check out Freedom Penguin for lots of great stories about Linux. You will find links to those different websites in the description to this video, along with my notes for what we talked about here today. So go off and make use of it and have fun.